Okay, here we're going to look at a special type of problem where we're not interested in a typical point, such as like the top of its path. Okay, knowing that this object goes much higher than 10 meters above the ground, so this object will reach a height of 10 meters with respect to where it was launched at two different times, on the way up and on the way down. Okay, so we would have to either solve two separate problems or use the quadratic formula, which gives us two real answers. Okay, so let's look at what we have here. We still have to separate the givens into x direction and y direction. We know that in the y direction, it tells us that our initial velocity in the y direction is 25 meters per second being launched at an angle of 60 degrees. We are looking for the time that is at height of 10 meters above where it was launched, and we know that this is changing under the influence of gravity. Okay, so from these givens, we're going to pick the equation that is quadratic. Okay, so I'm going to use the quadratic here because I think it is the most direct solution. So I have to rearrange this to put it in quadratic form. So I have 1/2 at squared plus v naught t minus delta y is equal to 0. And I know that x, so my x is going to be t. So to solve this quadratic formula, or quadratic equation, I have the quadratic formula, which is t is equal to negative b, so it's negative v naught, plus or minus. So remember, this is when it's going up, and this is when it's going down. That's what the plus or minus is standing for. It is a square root of b squared, which is v naught squared. This is minus 4ac. Now, 4a right here is going to give me 2 times the acceleration, and then my c is going to be the negative delta y. So I know this negative sign is going to cancel out the negative sign for the minus 4ac. So I have plus 2 times a times delta y. And again, notice that this is what the final velocity is going to be equal to. So we're looking at a positive velocity at this height as well as a negative velocity at this height. And that's where those two instances occur. All over 2a, 2 times 1/2 a gives me a. All right, so that's getting it into the quadratic equation, or the quadratic formula. Now we just plug in what we know. All right, so I'm going to plug this into the calculator, and that's 25 sine of 60. So I get 21.6. So I have negative 21.6. I'm going to leave my units out because it gets a little bit confusing in there. 21.6 squared plus 2 times negative 9.8 times positive 10. That's going to be all over negative 9.8. Okay. I always like to get it down to this number plus or minus this number all over that number. Okay, so I'm going to have plus or minus here. I got to solve for what the velocity is going to be at this location. Okay, so I'm going to do the square root of 21.6 squared plus 2 times negative 9.8 times 10. And close all those parentheses, and I get that this is 16. Let's round it up 16.5. Okay, now This is meters per second. This is meters per second. This is meters per second squared. So we can see that the units will give us time, okay? So you have to do two separate problems here now. You have to do negative 21.6 plus 16.5 divided by negative 9.8 will give us a positive 0.52 seconds, okay? Since it's positive, we know it's a real time. Now, since we just did the positive, we have to do the minus. So we're going to do negative 21.6 minus 16.5 divided by negative 9.8. We get another positive time equal to 3.9 seconds. Okay, so if we think about this, this is a short amount of time, it's a much longer amount of time, so we know that it takes us 0.52 seconds from launch to reaching the first 10 meters. It passes that, and then by the time it reaches 3.9 seconds, it's back at that same height. So the quadratic's good because it's the only way that you can really get these two answers. All right. Now, I'm not going to go through this solution, but there is a way that you can solve for what the final velocity is, the final y component of the velocity here as well as here, and of course use the way around the quadratic. You would just have to solve for the time it takes to go from this velocity to that positive velocity, and then this velocity to that negative velocity, and still use the equations to solve for time. You just have two separate problems that you have to do. Again, whatever way that makes the most sense for you is probably the best way for you to do it.